This is the video for experiment number 1, class Physics 430 Optics in spring 2014. This lab asks us to look at the spectral line patterns from several different lamp sources. So most importantly, here are materials. We have the spectroscope, as you can see here. Do note that we have several different options when we're dealing with our spectroscope. We have an adjustment on the size of the slit, which regulates how wide the light source is going to be coming in. On this end of the telescope, there's a crosshair. Both sides of the spectroscope have the ability to adjust focus, which is located on this knob on the opposite side. And if I swing this arm over here, you can see it right there. So that's the focus. This arm currently can move because these adjustments of the telescope arm are allowing it to. I tighten this guy, and then this doesn't move. The same is also true for this one right here in regards to the movement of the table. The table is the location for the placement of our prism. Stated in the lab procedure, equilateral prism. What we're using actually is a isosceles triangle prism. So you can see that the bottom's longer than the two sides. This prism can be placed in here, and we'll get more to that in the procedure. It's important to note that we had 3 different types of lamp. So this one I've got set up right here is cadmium. There was also mercury, Hg, and zinc. Also important to note on the spectroscope, and this is going to be a little bit more difficult to show you, but I'll go ahead and lift it up and see if you can see. That's our measurement of the angle, is that silver part right there. It's a Werner scale, so it's important to note that while after calibration we want the zeros to line up, we also need to take into account the minutes changed. So this is a very precise measurement we're attempting to get. Procedurally, when we start to actually try and perform the experiment, the most important step is to line up the spectroscope here with the lamp. I knock things out of the way a little bit, but we'll get it back lined up. Line the spectroscope up with the lamp and find an alignment where from the calorimeter here, the light source goes straight across to your telescope end where you see it as the observer. Once this has been done, this is your calibration point. So we don't need the prism for this part, but it is important that we make sure that we lock the table in its position by adjusting this guy. The prism can then be placed on the table, and this is a great source of error when you're placing the prism because any slight adjustment in the angle the prism is sitting at, for example like this or like this rotation, will greatly affect the angle at which the light comes out. So when moving the prism from between lamps or between measurements, it's important to make sure that you recalibrate your entire spectrometer each time you take the prism on and off. Also note, material-wise, this holder for the prism can be removed and adjusted. This top table spins as well, so you can have it set up this way or this way, which isn't going to change anything but which angle you need to move the telescope in order to see the spectral lines. After calibrating it, so we've calibrated it without the prism on. Have our telescope coming from the calorimeter and we're set. We're going to call that 0. Then, when we go ahead and place the prism on, visible within this end of the telescope should be the spectral lines for each lamp. We found within our experiment that for the mercury lamp, we were able to obtain 3 spectral lines as well as the original line. For the zinc lamp, we were able to find 3 spectral lines as well as the original light source coming through the prism. And cadmium, we were able to find 4 spectral lines as well as the original light source coming through the prism. So what's important to note is the angle that we're taking the measurement from, so if we're seeing a spectral line where my telescope's here, once I take that measurement of the angle off the Vernier scale, that's what's gonna allow us to be able to calculate the index of refraction for the prism. Knowing that the spectral line, based on the color, has some given wavelength with a range, and taking into account the angle with obviously the inaccuracies and errors that come into the measurement, we can get a rough estimate of the index of refraction for the prism, and actually graphically and mathematically show how the light source is feeding through the prism into our telescope and coming out in which direction. And so the differences in angle is the differences in wavelength, and using all these different measurements that we've taken from the 3 lamps and the combined 10 spectral lines, we'll be able to get a good basis for what the index of refraction in the prism is. The rest of all of that math and details about error can be found in the written lab report.